Myoglobin is a protein found in muscle, and, like haemoglobin, as you might expect, it carries oxygen. So, as haemoglobin carries oxygen around your body, myoglobin sits in the muscle, and what it does is it acts as an oxygen reserve. So if you have to run away from a big animal, you have a little bit of spare oxygen hanging around in your myoglobin. And, like haemoglobin, the key oxygen carrying compound is a pigment with iron in it called heme. Now, muscle is meat. Delicious, delicious meat collection of proteins. And as we cook it, we change the colour of the myoglobin. So from being a beautiful red colour, it then becomes a kind of brown, and then it becomes a blackened char, and we don't eat that. Now, it is possible to cook myoglobin in such a way that it stays pink. So one way that you can do this is if you cook it very slowly so that the heme doesn't get the chance to dissociate from the rest of the protein. So if you slow cook a stew with some beef in it, sometimes you'll find after many hours of cooking, the meat is still pink, but it's definitely cooked. Another way that you can do it is through curing. So if you add saltpetre or potassium nitrite to your curing mix, the meat that you make will be a pink colour after you've cooked it. So if you consider pork or ham, the ham has had saltpetre added to it, which forms nitric oxide, which binds to the heme in the place the oxygen would normally bind, to keep it a pink colour. And your pork turns grey during cooking and your ham doesn't. It's possible to cure without the saltpetre, but then you get these kind of grey rashers that, while being tasty, don't quite look right. Now, my favourite way to keep the colour of myoglobin is through barbecue. So if you consider a barbecue, you have fuel, and sometimes this fuel isn't completely burning. And you'll produce a little bit of nitric oxide and a little bit of carbon monoxide. And those of you who've taken first aid courses will know carbon monoxide poisoned people stay a very healthy pink colour. Although, naturally enough, they're not healthy. And so, the same thing can happen to the myoglobin in your meat. As you're cooking your burger, the outside of it cooks really quickly, and the inside of it cooks eventually. But in the meantime, some of this carbon monoxide and nitric oxide is diffusing through the meat. And at a point just underneath the surface, the carbon monoxide and nitric oxide is bound to the myoglobin to keep it from changing colour as it cooks. And so the next time you're at a barbecue and someone comes up to you with a beef burger with a ring of pink on the inside saying that it's not cooked, you can say, well, it is indeed cooked. It's just been infused with some carbon monoxide and nitric oxide.